Section 8.4, multiplying and dividing rational expressions. All right, we've done some of this before. We call it reducing or canceling. So what we're going to start with here, example 1 says A times C over B times C. Well, at first when we look at this, we'd say, well, we can cancel those C's. Well, you're absolutely right. We can cancel those C's, but let's take a quick look at why. This should be a little bit of review. A times C over B times C, we can split that up into A over B times C over C. We can, of course, see that this is going to equal A over B times 1. C over C is 1, just like 2 over 2 is 1, is X over X is 1, smiley face over smiley face is 1. Okay, so if we can reduce something down to 1, we can effectively cancel it because 1 times anything equals that anything. So that's the kind of principle we're talking about here. Okay, so if 1 times anything equals anything, what we have over in number 2 is two quantities that we're adding together. Now, 1 plus x does not equal x. So when we are adding quantities together, we can't use this same logic. That's a big problem a lot of people have when they start looking at rational expressions like this, is they want to start canceling C's. Well, we can't do that because we're adding two quantities together on top and on bottom. This is something we just simply can't do. So when we're adding quantities on top or on bottom, we have to remember that we cannot cancel those. So this is going to be our fully reduced form. We're going to say does not reduce. Okay, so that is our final answer for this guy. All right, let's move down to number 3. Well, now that we've just got talking about how we can't cancel things if there's plus signs involved, pluses or minuses, now we've got something like this. I'm going to go ahead and put parentheses around this to hopefully help you see what's going on. We've got the quantity A plus C over the quantity A plus C. Well, these two quantities are exactly the same, right? Well, we learned up here that as long as we have the exact same thing on top and on bottom, they're going to cancel. Well, A plus C is exactly the same as A plus C, so these two quantities, being the same, can cancel. Those will equal 1. So it works as long as they're exactly the same. It's very important to understand the difference between this guy and this guy. So take a quick look at that and make sure your notes reflect that. We're going to be using those properties a little bit later. Okay, we look down here now at number 4. We have 15 over 65. Well, there's a couple of different ways to look at this. One is just saying that we can reduce this. We can divide both the top and the bottom by 5. Well, sure we can. We will get 3 over, well, let's take a quick look at why it works. If we've got 15 over 65, we can break that up into 5 times 3 over 5 times 13. Split the fraction up. And of course, these will cancel or reduce down to 1. And now we get 3 over 13. Same thing we got up here. So I just wanted to show that this is why our reducing operation works. This is what we've been doing this whole time. Let's take a look at number 5 down here. We've got some quantities. We've got 4 times the quantity x plus 3, and 8 times the quantity x minus 5 times the quantity x plus 3. Well, take a look at this guy. Remember that we can cancel quantities as long as they're exactly the same, right? So I'm going to go ahead and take this x plus 3, and we're going to cancel it with that x plus 3. Well, that's perfectly legal. We've got quantities canceling quantities. As long as they're exactly the same, we're perfectly legal. So that's going to leave us with a 4 on top. We've got 8 times the quantity x minus 5. At this point, guys, we certainly could distribute this. But for the homework today, let's not do that. Let's leave it expanded but wait, like you say. This 4 can cancel with this 8. Well, you're absolutely right. We certainly can. We're multiplying down here on the bottom. On the top, we've only got the one term. So we can certainly cancel that. So let's do that. Let's take 4 into 8. We'll, of course, have 1 on top, 2 on the bottom, and let's not forget our other term. x minus 5. Okay, so we've got a 1 over 2 times the quantity x minus 5. And again, let's not distribute that 2 right now. We'll save that for later. All right, let's move on to the next page. A couple more examples. Simplifying. Okay, well, we just got done talking about how we can't cancel. We're on number 6 here. How we can't cancel when we've got this little plus sign in here. Well, let's break this top up and factor it a little bit. Note, we're going to factor first and then cancel. Well, let's try that out. If we're going to factor x squared plus 7x, I think I'm going to factor that as x times the quantity, x plus 7. We all see where that came from. We just pulled an x out in front. And on the bottom, we've still got x squared. Okay. Well, that x squared is really x times x, right? So we've got x something like that. Well, it should be pretty clear to see right now that we can cancel that x, and we're going to end up with x plus 7 over x. There we are. Now remember, guys, we've got this plus in here. There's no more factoring we can do. This is as simplified as we're going to get. That is a simplified expression. Okay, let's look at number 7. Let me make a little bit of room here because I know I'm going to need it. Okay, we can factor this trinomial term. Trinomial is 3. We're going to factor it into 2 binomial terms, right? This is a quadratic, so we can do our parentheses. We're going to factor this stuff we've been doing for a long time. Minus 2 and a minus 15. Let's see. We've got no lead coefficient, so we're going to have x and x. I think we're going to have a minus and a plus because we've got 2 negatives. Let's go minus 5 plus 3. Those multiply to a negative 15 and add to a negative 2. So I think we did a good job there. We've got on the bottom here, we have a difference of squares, right? We have this is a square, and 9, of course, is 3 squared. Right there. So we can break this down as a difference of squares. If we remember how to do that, let's find out here. X minus 3, x plus 3. Okay, I like that. Okay, now we've got quantities on top, we've got quantities on bottom. If we remember from our last page, we can see that, if quantities are exactly the same, they are, in fact, going to cancel. So let's go back over here. We've got some quantities that are exactly the same. I'm going to cancel this x plus 3 with that x plus 3. That, of course, will leave us x minus 5. Make that 5 look like a 5 over x minus 3. Now we've got a quantity on top and a quantity on bottom. They are not exactly the same. They're not going to cancel, so we are done. That is it right there. And last but not least, number 8 on the bottom says x squared plus 6x plus 8 over x squared plus 2x minus 3. Our factors up here, we'll have some factors down here. Let's take a look here. Plus 6 and plus 8, so we'll have plus signs, no lead coefficient. X is in front. We'll have pluses because they're both pluses. And let's see, how about a 2 and 4? I like that. Those add to 6 and multiply to 8. Yes, okay. On the bottom, x here, x here. How about a positive 3 and a minus 1? I like that. Okay, so we factored it out. We can see here that we've got 4 quantities, but lo and behold, none of them are exactly the same. So it looks like we're not going to be doing any other simplifying. This is our answer right here, as simplified as it's going to get. And we can write does not reduce. All right, I like that. That's the end of our lesson for today. We'll pick it back up tomorrow with the continuation of this section. Good luck on the homework.